Hi, this is Sharmin Akter. The topic of my presentation is embodied energy. Here in this figure, you can see the various uses of coal fly ash. The title of the paper is Embodied Energy as Key Parameter for Sustainable Material Selections, the case of reusing coal fly ash for removing anionic surfactants. Below this title, you can see the author's name as well as the journal's name where it was published. The paper was published in the Journal of Cleaner Production in 141 volume and it was published in 2017. The specific scope of the study was selecting a sustainable material in the case of CFA besides the other main parameters such as carbon dioxide footprint. Embodied energy analysis is an efficient method to employ. Also, CFA can be less expensive and more environmentally promising absorbent for removing surfactants over the conventional ones such as activated carbon. Here, the key question addressed was, could coal fly ash as a sustainable material be promising and desirable for removing anionic surfactants over the commercial one? The methodology behind this work was mainly based on HB material selections. Also, the kinetic model was applied to see the effect of initial concentrations of SDS on the initial absorption rate. The material performance indices used were embodied energy, carbon dioxide footprint, commercial price, etc. For the materials or process surveyed, glasses and ceramics, which are sustainable, were the main focus. The paper also showed a comparison between the CFA to activated carbon by describing the dose effects of both on SDS solutions. Now, which material is best choice considering the material index of embodied energy, carbon dioxide footprint and commercial price? Here in figure A is embodied energy of some materials used as anionic surfactant removal versus their European commercial price. The materials are grouped as a functions of material family, which are ceramics and glasses. And here the figure B showed embodied energy of some materials used as anionic surfactant removal versus their carbon dioxide footprint. Large differences can be found between the selected materials from these plots considering the embodied energy values. The embodied energy for activated carbon is higher than 20 megajoule per kg compared to the one of steels and cast irons. On the other hand, CFA shows an embodied energy value lower than 1 megajoule per kg. So it appears that CFE, which is at the lower left corner in the HB plot, is a very promising material as an surfactant. The percentage removal efficient, which is R, of an anionic surfactant of SDS by CFA was calculated by these equations. Here, C0 is the initial concentration of SDS and C is the concentration of SDS at time t. So, in this process, they took 3 SDS solutions which are mixed with different concentrations of CFA, such as 25, 50, and 100 gram per liter, respectively. The removal of SDS increases with the increases of a CFA dose. At concentrations to 100 gram per liter, CFA was able to remove SDS from water with efficiency up to 96%. So the dose effect of CFA on SDS solution is reported in that first figure. Removal of SDS by CFA with respect to time is showing in the second figure. The figure shows the result of kinetic study of the 6 solutions in which 10 gram of CFA is mixed with increasing amount of SDS. Why CFA can be considered as an efficient adsorbent over most widely used activated carbon. To evaluate the efficiency of CFA for SDS removal, a comparison with activated carbon is carried out. Two SDS solutions are mixed with same amount of CFA and activated carbon, and then the percentage removal efficient of SDS with two material was calculated by the equation that I showed you earlier. The removal efficiency of SDS was 81% and 90.5% with CFA and activated carbon respectively. Though the removal efficiency of activated carbon is greater than CFA, the comparison between embodied energy and efficiency results, it can be said that CFA is a potential option instead of activated carbon. It also considers the eventual coal regeneration and CFA recovery. In the figure, the proposed reuse of CFA after anionic surfactant adsorption should be beneficial in terms of increased sustainability of concrete productions. This figure describes the comparison between CFA and activated carbon as surfactant adsorbents. The key conclusions from the research paper. In this paper, it was found that embodied energy plays a vital parameter in selecting a sustainable material. CFA can remove a high concentration of SDS, which is a model surfactant here, in wastewater with efficiency up to 96% by observing several experiments. Several advantages are expected not only from the waste removal but also from an economic perspective and sustainability. In my opinion, this paper provides a different and insightful approach with the necessary information and the data that strongly supports CFA as an efficient adsorbent compared to commercial ones. It is a worth reading paper as it is not only contributes to selecting the best adsorbents material but also imposes the benefits of reusing the material to reduce the pollution. Before reading this paper, I was unaware of the various uses of coal fly ash. Thank you. Thank you all.